Okay, everybody, I'd like to welcome you to today's session or today's webinar. And today's webinar is on an introduction to what, why, and how of Cisco ACI. I'm sure some of you may well have some questions as we're going through, so please feel free to put those questions into the Q&A, and I will address those at the end of the actual session itself, and hopefully answer any questions that you may well have with regards to this particular technology itself. Before we actually get going on the material, what I'd first of all just like to do is introduce myself. My name is Karen. I have been a CCSI for some years now, and over the last 20 odd years, I have been very much involved in not only the networking environment, but also the storage area networking environment. And I have been working within the data center for the last 10 years. And I am currently, or I am an instructor, developer and consultant with Fastlane UK, which is the company that is obviously putting together these particular webinars along with a number of other things that we obviously do. I would like to introduce you to Fastlane as well. We are a training and consultancy company. We're very much involved in the whole IT environment. We do a lot of curricula with regards to various vendors, including obviously Cisco, and we are a worldwide Cisco learning partner who is specialized in that environment as well. And we do have training in a number of different countries, and we do have rather a large number of instructors on a worldwide basis. This particular webinar is one of several webinars that as a company we have been producing. And if any of you are interested in any of the previous webinars, they do cover a number of different subjects. It's not just Cisco related. There are subjects with regards to VMware, NetApp, etc. And if you'd like to view any of those particular webinars, please feel free to utilize the link that I'm showing here. You can find those webinars on Fastlane's community website itself. What I would like to start off with before we actually start discussing a little bit further with regards to ACI is just to put some context in place as to, hopefully will help to lead up to why we have ACI, and also to try and highlight some of the issues we have had and some of the issues that ACI may well be able to help you to resolve. And to start off with, if I recall back in my early days of networking, I didn't really care about applications very much. It was all about being able to connect some computers together, being able to get some devices talking to each other, not really worrying about how applications worked or what protocols we were looking at utilizing, because overall we generally had within that network operating systems and applications sitting on a single device, and very often the operating system and the application were one and the same. I'm sure some of you may well remember some of those early days of having to work with DOS itself. But of course, over years, everything has to look at evolving, and therefore evolution has occurred in the IT industry as well, where today we now have a lot more devices that we need to look at connecting to our networks. We also have a lot more connectivity requirements that we need to be able to look at supporting as well. And again, during that early evolution, we also ended up with lots of different languages and protocols that we had to look at maintaining and managing. And that provided quite a lot of difficulty when you thought about the different operating systems, the different protocols, such as Banyan Vines. Obviously, we also had IPX in those days. You had protocols like XMS, AppleTalk, obviously TCP/IP, and we wanted to be able to connect all of these devices together and get some form of communication going. And it was around this sort of time when Cisco obviously stepped in as a, for a better word, a neutral multi-language system, where they evolved and provided us with the ability to be able to get more complex networks in place and to be able to get communication taking place between lots of different protocols and lots of different languages. But of course, all of that has now evolved as most of you are aware, we don't tend to see much in the way of protocols like, or at least we don't see protocols like Banyan Vines, IPX, AppleTalk today, because today everything works across the TCP/IP protocol language, which makes it a lot more simpler for us when we're actually wanting to communicate between different devices themselves. So in those early days, we had to know a lot of different protocols, lots of different languages. That's now become a lot simpler. We've now centralized the actual protocol and also the languages themselves. And we're now also obviously having to think more about the application services that we're going to be running on top of those operating systems. And again, looking at that evolution, not necessarily where we are today, but applications have evolved. Initially, we were looking at running applications, single application on a single device, as in a bare metal system. To start off with, applications were built as primarily single-tier applications, the old mainframe days, where everything actually happened on the mainframe. We then gradually evolved into more distributed application solutions and multi-tier solutions. And then we had to start thinking about, as we introduced more and more tiers for our applications, how we were going to look at controlling the various traffic flows that needed to take place between those tiers themselves, which meant that we now started to need to understand a little bit more from a networking perspective how applications were being put together. We needed to know how those tiers needed to communicate. And then somehow we needed to be able to program all of our devices, such as our switches, our routers, etc., with all the policies that were required to be able to support that tier-to-tier, intra-tier, and inter-tier communication policies themselves. And we have up until now been very much reliant, or we are still very much reliant, on somebody actually sitting there and actually putting that policy together, programming that policy into the interface, and making sure that it is the right policy, adding to it, modifying it, as and when those requirements come up. And it doesn't make us very agile if anything needs to change, because if anything needed to change, we've had to go back to our interfaces, our devices, and we've had to make those changes ourselves. And as I'm sure we're all aware, it's very, very easy to make mistakes when you're looking at manually programming all this information into your network infrastructure itself. And then to introduce that complexity, or to make that complexity a little bit more interesting, we have very much within the data center over the last number of years been virtualizing at that server level as well, where now we've got to start thinking about this virtual access layer. We've got to start thinking about how we actually now program our policies at the virtual interface layer rather than just the physical interface layer. And at the same time, be able to look at supporting a lot more mobility of our virtual infrastructure itself. Because within our data center, our VMs are obviously moving around based on policies that our virtualization administrators may have set up, which then introduces more interesting and complexity as to how do we actually then understand where our applications or where our devices are actually sitting, what applications running where, how do we actually now make sure that the policies are still relevant regardless of where that VM is looking at moving. And very often what we end up doing is making changes to make things work, but not necessarily revisiting what we're actually programming into our interfaces, and very often being left with code that is no longer actually required. And that code remains in our network infrastructure and obviously makes use of resources which could be better utilized elsewhere for other policies and other parameters that we need to look at applying. So today, as we start looking at our network infrastructure, it is becoming a lot more complex. Our application services are becoming a lot more complex. There's a lot more tiers that we've got to start thinking about. And there's a lot more virtualization taking place within that data center as well. And then on top of all of that, when we start looking at what the business is requiring, the business needs more applications. Applications as well are being designed very, very quickly today. There's so many tools out there that an application can effectively be designed within hours, maybe days, depending on just how complex or simple it happens to be. But how quickly can we actually get that application deployed on the network infrastructure itself? Because that application has got to be run on a device, it's got to be run on top of an operating system, it's got to be connected to our network, therefore, and also it's got to be connected not only to the network infrastructure, but also to the storage area network infrastructure as well. Therefore, our actual deployment time is currently potentially taking us weeks, maybe months, to actually fully deploy a new application service for that particular business. And businesses today are looking at all of these services that they need to be able to offer, and they're now making demands on our IT infrastructure where they want us to be a lot more agile. They want to be able to say, here's a new application service, can you get it deployed? And they want it deployed almost instantaneously, much, much faster deployment times. And to be able to produce much, much faster deployment times, we've obviously got to have some way of being able to automate the deployment. We've got to be able to select something and it's got to automatically go out, and it's got to be able to say, oh, we need this facility here, we need this resource here, we need this configuration over there. And it's got to be able to do that in a much, much quicker way. And at the same time, be able to support the mobility side of it and potentially the removal of old code that is no longer required within our network infrastructure itself. So we're getting more and more demands being made for us, and we're getting out, and we're having to look at supporting more and more complex infrastructures and application services as well. So taking that concept a little bit further, we also have coming into play today this concept of SDN, software-defined networking. And part of the reasons why vendors are looking at SDN, implementing SDN within network infrastructures, is to try and take some of that complexity out, to try and make it simpler to be able to get our devices, our services deployed within the data center, and taking the complexity away from the edge devices and rather putting it into a centralized controller where we can go in and actually control what we want to look at deploying. The problem with SDN, or at least one of the issues that we have to be aware of with regards to SDN, is how do you actually support a multi-vendor equipment? How do we make sure that that centralized controller that we're now going to do all of our policy, all of our configuration through, can actually support any vendor's equipment? Because again, today, I'm sure most of you do not have a single vendor equipment inside your data center. You've probably got multiple vendors inside your data center. So how do we actually roll this out across all of that different equipment itself? How do we understand? How do we actually look at being able to program that vendor's equipment itself? Plus, we're also having a requirement today to start looking at the network infrastructure as a whole and saying, how do I better utilize it? How do I actually make use of the resources a little bit further, a little bit more, in a much better way? We need to be able to virtualize it. We need to be able to build the network based on what our application requirements are rather than what our network requirements are. So to take all of those potential complexities, potential issues that we're seeing inside our data centers today, Cisco's taken a much more holistic view of it and have obviously introduced this concept or this technology known as ACI, which is our application-centric infrastructure itself. And the idea behind ACI is to start looking at the application services and programming our network to be able to support the application service on the network. So in other words, look at what the application requires and put that requirement onto the network itself, but in a much more agile way, a much more automated way, so that if devices move around, policies can go with them automatically, but at the same time, we can automatically remove policies where they're no longer required. And that's effectively what we're looking at seeing here. That is the approach that we're looking at providing, looking at it, as I say, a lot more holistically, and looking at the actual application tiers and understanding what the application tier requirements are and putting that onto the network itself. So we're going to look a little bit further. So our three topics that we're going to look at for the next 45 to 60 minutes is going to be about what the actual application-centric infrastructure is, why it's important, and how we're looking at doing it with regards to ACI. So looking first of all at what is the Cisco ACI infrastructure itself. It is what they're calling here an application-oriented policy. We're now going to look at and say, right, we have a multi-tier application. We need to be able to control the traffic flow through certain tiers of that particular application. Therefore, we're going to build our policies around what those tier requirements happen to be. And by looking at it at the application level, it's also going to help us from an operational perspective to be able to maintain, manage, and also understand what's going on within our data center itself. And this is built to be able to support not only the physical infrastructure, but also the virtual infrastructure as well. It's designed to be open. Therefore, we can look at supporting multi-vendor equipment within our data center itself. It's built to be able to support cloud-based solutions, which we may well be looking at deploying. And it's built to be able to provide secure segmentation of different tiers, different application services that as and when they are required here. And that's effectively what we're looking at being able to see. And on the ACI side, it is all built around our Nexus 9000 equipment and our APIC. And basically the Nexus 9000 effectively provides us with the platform that is going to deliver our connectivity policies as and when they're required. And then we have our APIC, our controller, through which we can actually program our requirements at an application level that can then get pushed down to our Nexus 9000s, our actual devices, where we can automate the deployment of those policies in a much faster and much more agile way inside our data center itself. And it's all built around providing us with this framework. You know, we have multiple multiple teams inside our data center. You know, I'm sure you've all seen, you've got, you know, if you are building a cloud environment, you'll have a cloud administrative team, you'll have an application, a security, a network team, and they all understand their own areas, but from a networking perspective, I don't necessarily understand exactly what those application requirements are. So by bringing all of us together here and saying, let's program at the application level, and at the network level, we provide the actual resources, and being able to also insert into there the policies that are required to provide secure delineation between different tiers as well, we can create a common policy and operations framework that allows us to be able to overlay across our infrastructure what our requirements are. It also means too that from a networking perspective, the resources that we're deploying, the servers, the VMs, the switches, the routers, etc., all become just a common pool of resources. We're effectively going to treat that as a common pool of resources here, over which we're going to look at deploying these application services themselves. And that is primarily what our goal is looking at being able to do, being able to look at it at a much higher level, being able to use the resources that we have, and being able to automate the actual deployment of the policies that we require. But where do we today have to extend that policy? Well, this is the other thinking behind ACI. We know that applications are everywhere. We know that the network is basically what everything is connected to. So what we're going to effectively do is we're effectively going to communicate to the network what our policy requirements are, so that wherever something connects into the network, doesn't matter whether it's at the edge, doesn't matter whether it's in a cloud environment, we can just push that policy out to where it's required. In other words, we can extend it anywhere within the network based on what our actual application requirements happen to be. So that is what we're looking at being able to see. So it is physically, it's obviously our Nexus 9000s, our APICs. It's being able to take a group of people, bring them together to create the policies that we actually require, and being able to automate those policies being programmed down and out onto our network infrastructure anywhere where the application is connected to the network, whether it's a physical connection or whether it's a virtual connection itself. So why is there this requirement? Why is this important to us today? Why is it important to start looking at it at an application level rather than at a physical network level itself? And to look at why it's important, we need to understand, first of all, some of the challenges. And today there are a number of challenges. As I say, how do we look at supporting that mobility? How do we actually create a policy-based network that actually learns? In other words, how do we actually create an auto-learning infrastructure? How do we speed up the delivery of our services? How do we look at reducing our total cost of ownership? And how do we look at providing an end-user experience that is what the end user is expecting to get with an integrated solution itself? And the business wants all of these things. It wants this mobility. It wants this policy-based learning. It wants this catalog-driven infrastructure where end users can select what they actually want. But the infrastructure is not necessarily built today to be able to look at supporting it. And that's why ACI is needed here, because ACI is designed to take these infrastructure challenges and basically remove them. In other words, simplify the way that we're actually looking at programming and managing and viewing our network infrastructure itself. And what ACI brings is an application-centric policy model. You go into your APICs, you go into your controllers, and you specify how you want applications to communicate. You specify which services are part of that application, how many tiers there are within that application service, and you define what those policy requirements are. We then look at where we're connecting devices. So you'll connect a physical device or you'll connect a new virtual machine to your network infrastructure, and we'll be able to detect and see that a new device is connected, and we'll then be able to look at pushing that policy down to the actual edge where it's required. It's also designed to be open and secure. Yes, there's an APIC for control to be able to look at managing and controlling and setting up the policy requirements. But what if I want to look at integrating into a third-party integration tool? What if I want to make use of orchestration tools? In which case, we've also got to be open and have open APIs that third parties can communicate with, so that we've got both northbound and southbound traffic flows that can, again, help us to be able to speed up and become more agile within the data center. We then also want a lot more analytics. Today, how many of you could actually say that you have full application and network visibility? How many of us can say, yes, I can see that virtual machine, I can see how healthy that virtual machine is, I can see how healthy that application is. Today we can't. We don't have the tools where we can say that application is healthy, or that VM is healthy, or that switch is healthy. So one of the other concepts behind, or one of the other things that ACI brings, is this ability to provide us with a lot more visibility into what's happening within our network infrastructure, but at an application level, not just at a network level as well. So we get a lot of telemetry, we get a lot of health metrics from ACI as well. It's not just about programming everything, it's about feeding back to our controllers, feeding back to our tools that we've got out there, so we can see fully what's actually happening, what's going on within our data center itself. To be able to do that, we have to have a control system, as in our APIC, and there are two approaches to how control systems can look at working. We can have what they call the imperative control system or the declarative control system. And when we start looking at some of the solutions that are out there for software-defined networking, some are built around imperative control, which is where we effectively have to know how to configure an end device. As in, I'm going to set up my policy on my controller, but I've got to be able to build what the configuration looks like. And then I've got to be able to push that configuration down to the network device. The problem with imperative control is, how can a controller know how to configure every single aspect? So what you tend to end up with, if we're not careful, is simple basic instructions. In other words, we can't necessarily take advantage of some of the more complex features that may be available on that equipment. If we compare that to a declarative control model is where we tell the device what we want to achieve, but not necessarily how to achieve it. And the analogy they've got here is the air traffic control. Air traffic control has to provide the pilot information about where he takes off from, where he lands, which runways he should use, and obviously where he should be docking his plane. But the one thing that the air traffic control doesn't do is he doesn't tell the pilot how to fly the plane. We provide the information, we provide the end result we want to achieve, but we don't provide the details as to how you get to that end result. And a declarative control model gives us a lot more flexibility, because now I don't have to know how to configure every single device that is out there. I just have to know how to explain what my end result requirements are. And that is the way that ACI has gone. It's gone down the path of using the declarative model, where we do our programming, we specify what we want things to look like, take a very simple 3-tier model: web, middleware services, database services. We know that we want our users to communicate directly with our web services. We want our web services to communicate with our middleware services, and we want our middleware services to communicate with our database services. So we put in what our requirements are, what we want it to end up looking like, and then we push that down to the actual edge devices themselves. So we would then push that information down from the controller to our Nexus equipment, effectively saying, this is what we want to achieve, now do it. And we're now relying on the equipment to actually do the configuration. We're not actually saying how to configure it. We're asking the equipment, we're asking the devices to actually self-configure themselves. And by doing it that way, it gives us a lot more flexibility. And at the same time, we will also be getting feedback back from our equipment, where if I'm asking it to do something that it can't do, then it will come back to me and effectively say, can't do that, not possible, and it will generate that as faults, etc. within the system itself. So it gives us a much more object-based model. What they call objects are basically responsible for requesting what the configuration requires. There's no assumptions made about what the current object state happens to be, but it gives us a very mobile system because I'm only applying what my requirements are where I need them. And when those requirements are no longer needed, we can effectively remove those policies, freeing up resources for other services to be able to use. And that is what this decorative model is looking at providing for us. So what we end up with is we end up with our administrators sitting up at the very top, using this object-oriented data model to actually manage the logical objects, and those logical objects then get pushed, or the policies associated with those logical objects then gets pushed down to the actual ports, the virtual network infrastructure, the physical network infrastructure that we've got in our data center, otherwise known as the actual concrete model itself. So it's a much more agile system that we're looking at being able to see. Statement from Cisco, stateless hardware will change networking. Yes, it will. We're now worrying about policies and profiles. We're not worrying now about programming the hardware. The APIC is going to push the policy requirements down to the hardware. Hardware is going to program itself. That's how we're going to become more agile. And as we become more agile, it also means too that with ACI, or with the concept of ACI, we're now saying this is what we want to achieve, but we don't have to specify how we're going to achieve it. If we don't have something like ACI in place, then our poor administrator has to sit there thinking about how do I configure it, what do I require, and all of that takes time. So with ACI, we get a much faster operational model than we would have potentially without ACI itself. And that's where this concept is going through here. So how do we actually do it, or how does ACI actually do it? We've got this infrastructure, which appears to be a self-programming infrastructure. One can see why it's important, because we need to be able to speed up and automate our deployment a lot quicker. We can only do that if we have decorative type models inside our data center for programming purposes. But how do we actually do it? How do we actually make sure that we're grouping devices together correctly? How do we actually put together correctly what our application network profile should look like? So when we look at how ACI does it, ACI's policy model brings the concept, first of all, of what they call endpoint groups. So today, how do we actually group devices together? If we take the traditional multi-tier network infrastructure, access, aggregation, and core, we're probably grouping devices together based on VLANs. Okay, so everybody in or if we've got a bunch of web servers, put all the web servers into VLAN 10, put all the database servers into VLAN 20, put all the middleware servers into VLAN 15, for example. So we're grouping everything based on a VLAN and therefore a subnet ID. But is that web server only offering web services, or is it offering other services as well? What if I need to actually connect my web servers to multiple switches and they don't all support that particular VLAN because maybe they span across multiple aggregation layer pods? So the concept behind ACI is to create what we call endpoint groups. And an endpoint group is a collection of a service. In other words, I'm not looking at it at a VLAN level, I'm not looking at it at a subnet level. I'm saying I want to put into that group anything that offers this service. I don't care what the rest of the network infrastructure looks like. I don't care where you've actually physically connected it to your network. If it's offering a web service and it fits my requirements for this endpoint group, then that service is going to go into that endpoint group. I'm looking at the application level. I'm not looking at it at the network level itself. So our EPGs become a grouping of endpoints that are going to look at representing an application component, completely independent of our network constructs themselves. But we know that those, or should I say within that EPG, I'm no longer constrained to a specific subnet, because I'm now going to actually apply my policy at an EPG level, not at a VLAN level or a subnet level. So if I've got a service and it happens to be available on devices that span multiple subnets, then hey, they can go into the same EPG. And we can see here we've got a couple of EPGs, Web 1 and Web 2, and inside both of those EPGs, we've got different subnets. But it doesn't matter because I'm not looking at the subnet level, I'm not looking at the VLAN level, I'm looking at the application level and saying I need to actually enforce this policy at this application level itself. We then also have to think about, or we have another concept, should I say, known as an application network profile. Applications are not single-tier applications, they're multiple tiers. There's multiple service components that are going to look at comprising of that application. An application could be a 3-tier model, it could be a 5-tier model, it could be a 10-tier model, it could be a 20-tier model. But all of those tiers make up one application. So the next concept we have is what they call application network profiles. And an application network profile is, in effect, groups of EPGs that define an application. So taking our very simple one that they've got here, web, middleware, and database, those three services basically comprise of my application network profile. So I would group them together into what's known as an ANP, and then I would define how I want to allow communication to take place between those tiers. So how do I want the web services to talk to the application services? How do I want the application services to talk to the database services? And we would look at putting that together into this application network profile. And to define how we want to be able to communicate between those tiers, we create contracts. And you will either provide or you will consume a contract. So for example, I've got my web application or my web service. I want my web service to provide a web service to my external users. So my external users would consume the service that my web service is offering. And my web service would be providing an HTTP service or an HTTPS service based on your protocol requirements. I then need my web services to be able to talk to my application services, my middleware tier. So therefore, because the web service wants to use services that are being provided by the application tier becomes a provider and the web becomes a consumer. And likewise for the back end, where we've got the application and the database services, application becomes a consumer of services that the database service has to offer. And we're effectively setting up the contracts. We're defining how these EPGs are going to interact. And within our data center, because this whole model is built around what they call a whitelist model, within your tier, in other words, within your EPG, you can communicate, so all the web services can talk to each other, all the application services can talk to each other. But if you want to be able to talk outside of your EPG, that contract has to be in place, therefore creating, in a way, a deny all policy across our network infrastructure with strict controls in place as to how we provide that communication service itself. And that's what the contracts are looking at providing for us. And we will create those contracts for outside communication as well. For example, inside my ACI infrastructure, I've got my multi-tier application service, but my actual users are outside of the data center. So I would create what's known as an outside EPG, and I would put together the policies that define how somebody from the outside EPG can communicate with the front-end service known as our web service here. Therefore, everything gets assigned to an EPG, and contracts are put in place to define how those policies are going to take place. So outside EPGs are associated obviously with your external network policies, and you can put in things like QoS, your filters, your ACLs, just as you would do normally to provide that communication flow. But what about our service modules or our service appliances? How do we look at then adding these in? Within our data center, taking out our traditional multi-tier model, access aggregation core, you've probably got firewalls, load balancers, IDS devices, etc., all sitting very often at the aggregation layer itself. And today we have to enforce through our configuration the requirements for certain traffic to go through those external services. And it's not always easy to do that and to make sure that we have got those services physically deployed in the data center so that we can actually get those flows through those devices themselves. So again, ACI simplifies that. I can connect my service appliances anywhere. Doesn't really matter where I connect them, because the actual service graph that we're going to create and associate with our contract will effectively define what the traffic flow looks like. Again, take an example. External users want to be able to communicate with the web service. In front of the web service, I've got a load balancer and a firewall. So my contract would have included within it a service graph that says when my external EPG users try to access my web service, send it through this firewall or this group of firewalls, then send it through this load balancer before it actually gets to the web service itself. So we're effectively now defining what we want the actual traffic flow to look like. But doesn't matter where that physical device sits or that virtual device, because it could be a virtual appliance sits, as long as I can reach it at an IP level, then I will be able to forward that traffic through that device and ensure that we are still applying all those additional rules themselves. So again, it makes it a lot simpler to be able to look at incorporating those service modules and appliances into our data center. And it's all built around this service graph where you define what services you require. And you can use this service graph multiple times. It's not restricted to a single contract only. And effectively, we've now got our services included into our contract and included into our actual traffic flows themselves. So the concept is EPGs, application network profiles, making sure that we have contracts in place to specify how communication is going to take place, and also obviously including into those contracts any services in addition that we need to include too. So what does the actual fabric look like? What does the ACI fabric look like? So again, a little bit more about what it includes: leaves and spines. So we have ACI spine nodes, we have ACI leaf nodes. We have our application policy infrastructure controller connected to our ACI leaf nodes, and effectively we connect everything to the leaf nodes themselves. And our spine nodes become just basically bandwidth, okay, backplane connectivity, crossbar connectivity, Think of that ACI fabric as, in a way, a dirty great big switch, okay, which we're going to go through. And what we're going to provide here is what they call full normalization of the ingress encapsulation mechanism. Within the ACI fabric, everything is forwarded via the use of VXLANs. We're going to connect everything edgewise to our leaves. And anything that comes in on a leaf, we're going to look at the header, and we're going to associate it with an ACI VXLAN. So therefore, when it comes into the actual leaf, doesn't matter whether you come in with a tagged VLAN, another tagged VXLAN, whether you come in with an NVGRE tagging, we can normalize that at the leaf so that we can actually send that traffic from one leaf to another. We're going to also provide what they call a distributed layer 3 gateway. Right now, we have to define in our traditional network infrastructure, data center infrastructure, we have to look at defining where our first hop redundancy protocol is going to sit. Where are we going to deploy it? And every time we want to be able to go from to provide any VLAN to VLAN communication, we have always traditionally had to forward it to that default gateway to allow that communication to take place. Within ACI, we have a distributed layer 3 gateway. Basically, every leaf becomes the gateway for whichever VLANs or subnets it has connected to it. That way, we don't have to introduce additional hops to be able to get to a default gateway. Because we're also looking at doing host-based routing within this infrastructure as well, we're also removing the flooding requirements. So things like ARCs, gratuitous ARCs, etc., they actually all now stop at the leaf nodes themselves. There's no requirement for all of these types of broadcasts to be flooded across the ACI fabric as well. So again, optimizing how we're using our bandwidth and how we're looking at providing communication processes through that fabric itself. And this whole detail, as I say, is all related to decoupling the endpoint address from the location of where it actually sits, and basically now saying whatever your endpoint identifier happens to be, you're now associated with this location, and this location is reachable via our ACI VXLAN infrastructure that we've got here. So we have some mappings in place that is going to be provided between VXLAN tunnel endpoints that are going to be residing on each of our leaf switches themselves. And we will make those forwarding decisions at the actual leaf. All our spines need to provide for us is just bandwidth, the ability to be able to forward traffic from one leaf node to another leaf node. And all of this is done seamlessly within the ACI fabric. All ports can support all encapsulations, so there's no restriction there. Policies, as I say, are all defined through the EPGs themselves, so everything, encapsulation, normalization, forwarding, and policy, fully decoupled itself, providing for us an any-to-any connectivity. So proper any-to-any connectivity is provided because you can talk from any device to any device within this fabric. We just need to have the policies in place, contracts in place that define how that communication process should be taking place. You've also got full integration with various virtualization solutions. Today, unless you've got an integrated Nexus 1000V or some other integrated solution on the VMware side, you probably don't have visibility into what's happening at that VM level. But with ACI, we've now got that integration, and we can integrate in a number of different ways. We can integrate through the traditional DVS. We can integrate through vCenter, vShield Cloud Solutions. We can integrate through AVS by deploying an application virtual switch down at that level as well. So we have got that full integration, so we can have full visibility to the actual VMs so that we can push our policies down to that VM level itself. And we can do the same with Microsoft. So effectively, any of any virtualization solution, we've got that integration or interaction with ACI so that we have got that much more tightly packed integrated solution for any data center itself. And this is just a couple of the options or the two modes of operation that are available on the Microsoft side. You've then got full orchestration and management capabilities. Doesn't have to be UCS Director, but obviously UCS Director is one of the orchestration tools that are available. And through our orchestration tool, such as UCS Director, we can look at creating our catalogs so that when a user makes a request for a new virtual machine, for example, they pick what they require. They provide any specific information that is needed to be able to build their VM. And then we push that requirement down to the APICs through our UCS Central, through our UCS Manager, so that we can actually push those requirements and automate the build of that new VM through this ACI infrastructure too. So we've got that full integration within here so that we can look at managing not only Cisco environments, but also heterogeneous data centers and converged infrastructures that we're looking at building today. So you've got this integration. The UCS Direct Orchestration with ACI provides a lot of workflows. They're already there, available straight out of the actual box. Obviously, you can create your own workflows so that you can actually provide that catalog of services that are available. And all of a sudden now, we become a lot more agile, and we're actually able to start programming our data center infrastructure a lot faster. You want a new application put out, provide us with the details of how that application needs to communicate. We'll put those policies into ACI. ACI will then deploy it, or at least the ACI infrastructure will then deploy it, and you can have that application service up and running a lot faster than you did previously before. And all that automation is there across a multi-tenanted solution as well, because we also want to be able to support a multi-tenanted solution so that micro-segmentation can be provided in a very secure way within that data center too. So we have this capability along with with the UCS Director itself. We now start looking at what the business requires. So we've got our segmentation based on the business requirements, what the business needs. I've been talking about within an EPG, you can communicate, but if you want to be able to talk outside of your EPG, there needs to be a contract in place to be able to support it. But we're also going to get a lot more micro-segmentation so that if we need to do any restrictions within an EPG, that capability will be available as well. And this is being pushed down to the container level so that even at that container level, we can provide that micro-segmentation capability too. So what are your requirements? What are your workflow requirements? How should your application work? And you can set up, obviously, segmentation by production, test, development, DMZ, whatever that business requirement happens to need. Okay, so look at what the business needs and provide that micro-segmentation level itself. And that's available today, and it will integrate in with a number of services with our service modules. So obviously you've got that full integration and service automation itself. So how do we configure it? If you are looking at obviously going down this ACI route, there is a GUI, obviously. There are APIs. So one of the tools that are available for us to use here is also programming languages And we do have CLI, NXOS style commands that we can use. So we've also got full flexibility on that configuration side too. So in summary, what are we looking at? What is ACI about? It is a first of all, it is a tightly coupled policy-driven solution. It's designed to look at integrating software and hardware. It's a management and policy framework where we're going to look at defining what our policy requirements are and be able to look at managing everything through our central infrastructure, or our central management infrastructure itself. Why is it important? It's a lot more application focused. Businesses today, as I say, need to be able to deploy their application services a lot faster. Being able to deploy application services a lot faster means we can bring revenue streams on a lot quicker, all of which is good for the business. So we've got to become more application focused. We've got to start looking at our network infrastructure as a pool of resources rather than a switch that's providing this service or a router that's providing this service. We've got to be able to program it and be able to add and remove requirement policies as needed. How does ACI look at doing it? Makes use of our central control of the APIC. We can define all our requirements through put all our application requirements through our central controller. We can then automate the actual deployment of that configuration. You plug something into the network. It says, oh, I've got a new one of those. What do I need to do to be able to support it? But it will also provide us with a lot more visibility into not only the health of our network infrastructure, but the health of our application network infrastructure as well. So we can see a lot more about what's going on at that application level. And it has been designed from the ground up by Cisco to be application-centric. It wasn't a case of taking something that was already there and trying to modify it to support an application-centric infrastructure. This has been built totally to be able to be an ACI infrastructure itself. And that's effectively where it's looking at going. So that is our overview, or our webinar on just a little introduction to what ACI is about. If there are any questions, please put them into the Q&A. There are a number of references, just so everybody is aware. There are a number of places that you can go and look to get more information on ACI. There is obviously Cisco's website, but if you go to Cisco Live, some of the documentation that has been provided up there gives a very good insight, further insight into where ACI is looking at going and what it's able to look at providing for us within our network itself. So I would like to say thank you for attending. I'm just going to close this for a moment so I can actually see if there are any questions and answer any questions, any Q&A. So if anybody's got any Q&A, please feel free to put those in, and I will be more than happy to answer any questions. Thank you. Are there any questions from any of you who've been attending? No problems. Thanks, James. Okay, if there's no questions, everybody, I will close the session down in about 3 minutes' time. Thank you.